Stecker raus. Good morning or good afternoon. Welcome to Bystronic here in Switzerland. Last Tuesday we showed you our excellent solutions for laser cutting and automation for laser cutting. Today, in the next 60 minutes, we want to show you our excellent solutions for bending and automation for bending. With me today is Gerrit and Tan, and these two guys are the guys with the most knowledge and experience about bending. At any time, please use the chat to write questions and we will answer it as soon as possible. Okay, enjoy it. Thank you.
Okay. Thank you. This is Tan. He's going to do all the bending and I'm going to do all the explaining. We try to keep away from all the technical details because that is just boring and we don't really want to know how many tons this 150 tonner has because it already is written on the machine. So what we're going to do, we're going to show you how these machines work and how you can use them to make more money for your company. I know you have some of our machines. I also know that they're pretty old. There was even one I commissioned personally. That's a long time ago. And since then, we have moved forward at an incredible pace. These new machines are called Pros, Expert Pro. And the Pro is there to show you that the machine has become the professional and not the operator anymore. Of course, we need operators, but they don't need to have like super much experience. They don't need to be a professional press brake operator because the machine has taken over all these very important functions where the operator had to think about in the past. Now the machine thinks about it. So we compensate everything which is deformation on the machine, on the material, on the tools. All these deformations are automatically compensated, so the operator doesn't need to think about it anymore. Thank you, the laser is now off and we can hear ourselves. Good. Tan, first thing we're going to bend is this crowning part. Okay, I'll explain the crowning, how does that work. We have, behind this cover, we have 3 crowning cylinders. Depending on the length of the machine and the tonnage, we have more or less crowning cylinders. These crowning cylinders push the lower beam in exactly the same shape as the upper beam. When we start to bend with the 2 main cylinders, of course you get a bow shape in the upper beam, and the big trick is how to get to compensate for that bow. What we do is we make exactly the same bow in the lower beam, so now the distance between the upper beam and the lower beam is the same everywhere on that machine within a hundredth of a millimeter. I cannot tell you this in inches because I can't calculate so fast. A hundredth of a millimeter is very, very small. So what happens is that we measure with pressure sensors, very precise pressure sensors, in the main cylinders. We measure exactly how much pressure the part takes, this part for example. So obviously if we bend here or here, we need a different pressure because there's lots of holes here and there's no holes here. So this pressure varies. It doesn't vary only because of holes, of course. It also varies because of tensile strength variations. It varies because of thicknesses. It varies also where you bend on the machine. The machine is going to be deformed automatically differently. And we compensate for it, all that in real time, all the time. And the operator, even a good one like Tan, doesn't need to think about it and he doesn't need to compensate anything. He doesn't even need, probably knows how to program it. So what we're going to do first is to mount a little dial gauge indicator on the machine so you can see what's happening in the mechanical life of the machine. So put it on 0, or it is already on 0, marvelous. So what will happen is that the top, this middle beam will move up, and the part where the magnet is, it will move down a little bit. So this moves up and you will see that this moves in the clockwise direction. We have put a part in the machine already, as this part here. And as you can see on the screen, you can see that there's no holes here. Yeah, this is a full part. It's Domex 700, so it's pretty hard material. We need like 50 tons through the full material, and we need like almost no tons if we bend a small coupon. Now Tan will take 2 coupons out of the part, the main part.
I'm going to take 3 of these
Oh, 3.
Small blades out from this part, and I'm going to show you, later. First, I'm start with the first one.
So we're on the first bend now, and you will see that the dial gauge indicator will move a tiny little bit, because even a small part like this has a little bit of force, and it also needs a little bit of crowning. So that's our reference part now, right?
So we're going to keep that part.
We put it somewhere, and now we're going to bend through this part, and normally, yeah,
Start from here.
we start from there, good. So Marcel, if you, oh yeah, you can film this here, that's okay. So this is a little bit bigger than the small coupon, but not much. So it will move a little bit more. You saw that, like maybe 400 or 500 more. And every time we move through the part, we have more material to bend, and we have more crowning. Yeah. So again here, a little bit more material, more crowning. And this is all done automatically in real time without any operator intervention. So no thinking, best results. Last bend, we need almost 50 tons here. There we are. And then,
So you can keep that part,
yeah.
in another position.
So now everything is different. Now we move the part on the machine, but we didn't tell the machine. So what's going to happen? That cylinder, the Y1 cylinder, the left cylinder, needs to push a lot harder than the other cylinder. And while we bend, wait a minute, wait, you have to film here. Wait here. Yes, okay. So here we see how much the side frames bend. So if you bend now, you will see that the first one, this one, will move a lot more than this one, because the part is now all the way on the left side. Yeah, bend. Yeah. There, so that was almost 0.6 on the left side and 0.2 or something like that on the right side, the right cylinder. We're going to bend the small coupon again, also now completely on the left side.
We have 2 left. Want to repeat that plate in another position. And the other one, we turn the part 90 degrees to the grain direction, and we bend somewhere here. And when we want to compare all of these 3 plates with the 3 different conditions, and you will see the result.
So these are exactly the same. And then,
now we are going to check all of this.
so these were the first bend, second bend, third bend, fourth bend, fifth bend, and this is the one we bent all the way on the side of the machine. The results are exactly the same all over the part, over the length of the part, and all this because the machine has become the expert and the professional. So this is one of the most important features on all our machines. All the experts have this dynamic crowning, and the dynamic crowning will make that your parts are the same all over the length, all over the machine. Wherever you bend, no matter how long the part, no matter what material quality you have, we will figure it out during the bend, and we will make that angle the same all over that part. So if you have a 10-meter machine, you will still see this result. If you have a tandem 2 times 10 meter, a 20-meter machine, then you will still see this exact same result. So that's the first little part. Next thing is, I think we're going to do a tool change, right? First we need to get rid of these tools. So on our machine we use a system which is called RFA. RFA means, let me get a little tool. Yeah, from here maybe. No, wrong cabinet, they're here. So RFA, these are our standard tools for our machines. You can see we have this dovetail here, where the tool hangs on the dovetail in the upper beam. And here we have some wedges pushing the tool up when we close the clamping. So we take these 2 off first. It's very easy. You can load these tools anywhere on the machine. You know, even doesn't matter if you want to put them back in you can load these tools anywhere on the machine. You can shift them left and right. And this is like a super fast tool clamping system. What I was going to show you with this small tool, because this one's too heavy for me to carry, this is how you hang them in normally. And of course, you can also reverse them like this. So all tools we have, all top tools, can be reversed. Yeah, that's a big advantage if you have gooseneck tools. I thought Tan was going to help me, but no.
Excuse me.
Okay, so the next little thing is we're going to show you the next big step in automation, which is the tool changer. So behind the machine you see this robot. It looks quite big, and that's because it is quite big. That robot can grab any of the tools you see behind this machine. We can have a tool storage of up to almost 40 meters of different tools. We can stack tools up to half a meter in length. We can do tools a V120, you see in the left corner there. That's a big V120. And we can move tools with a total weight of 25 kilos. That's huge. You know, you as an operator do not want to move tools with a weight of 25 kilos. What can we do more? We can have tools which are up to 350 millimeters tall. So these are quite big tools. We can store in the top range of these racks. We can have higher tools than our standard 250 millimeter tools. 250 millimeters is 10 inches, I know that. Okay, I think we move out of the light guard. Another couple of interesting facts on the tool changer. There is absolutely no programming involved. The operator doesn't need to program anything ever. Yeah, Tan is going to reset,
Marcel,
and Marcel is going to move out of the light guard.
Yes.
And then the robot will wake up and it will start changing tools. Now, in the beginning, this looks like it's like, not the super fast movement of the robot, but you need to remember that we can still move tools which are 25 kilos in weight, and that is absolutely huge. Tup, tup, tup. Maybe we need to hit the foot switch?
No.
No?
It's too soft. I don't know.
Aha. Okay, our cable.
You don't need to move that one.
Ah, we don't need to move that one. Okay. So we have a light guard which works really well.
So, good.
There we go.
So we have, yes, we start.
There's a couple of different options with the tool changing. Right now we're just going to put new tools in the upper beam. You can remove all the tools from the upper beam. We have some filters where we can say, show me all the tools which have had 10,000 bends on them, and then we can inspect them, see if they're still okay, see if there's any wear on the radius or something like that. As I said before, there's absolutely no programming, so whatever program you pull out of the memory, there will be a question. You want to load the tools manually, or do you use the tool changer? Both are possible.
Nicht so weit machen.
But you can also see on the robot head, on the right side of the gripper, you can see a little blue laser thing. You see the laser sticker on there. Now that laser measures where the tools are. So if you want to put new tools in these magazines, you do not need to ask anybody to come. You can do it by yourself. You just put the tools by hand in the lower beam or in the upper beam. And then that laser scanner will find out where the tools are exactly. It will figure out how long they are, and it will also figure out the type of the tools. The type of the tools means that we know exactly if it's a P5, a P7, a P4. These are our tool names. Of course, you can name them whatever you like. And then it will ask the operator, I found a P5 200 millimeters and it's here. The operator says, yes, that's what I put in there. And then the robot will find an empty spot in the racks, and it will put the tools there. You don't need to tell the robot where to put the tools. I've got a special cycle here to go to the sides. And we can use the whole lengths of the upper beam. We can go even outside the length of the upper beam if you need to do a special bend on the outside. Once the tools are in, the robot is going back to its initial position again, and it will go back to sleep, just like now, and we can start bending. Okay,
Yes.
so this is first little step. What we can show you here on the screen, Marcel. Here you have all the information of all the tools we have in the machine. So if you click on one, this one for example, you want to see the details of this tool. Yeah, this one has been used only 3 times. It's 550 millimeters, it weighs 13 kilos, and you can see where it is. And you can also say, delete this tool, because we only have used it 3 times. I should figure out something better to do with it. Or you can just leave it in there, doesn't matter. So all these things are available for the operator. You can see everything. You can remove tools from stock. You can load new tools. And there's also an info here where you can see which tools are in there right now. If you're very patient, you can read all this. It's basically all the tools you've put there in once. You can still see what they are. Are we going to bend something?
No.
No, okay, we're not going to bend something.
Just to like to show you the smart segmentation.
Okay.
If you want to change to the next job, you know, the robot is going to manage the segmentation by itself. And you will see here the next bending programs will be changed something like that, and we let the robot manage by changing the tool by itself. Let's have a look how this works.
So this is what we call smart routing. Smart routing means that the robot, he knows now which tools are in there, and he's going to add tools. He can shift tools. He can also put tools on a parking position, so to be used later on. It's probably what he's doing now. This is like a parking position. So it's put some tools already in the new positions, and then afterwards it will grab these tools and put them on the initial position where they should be. If I look at how much time you're going to gain by using a tool changer, in general, an operator uses more or less between 12 and 20 minutes to change tools. This is what we see on our machines. Even with the fastest clamping system in the world, it still takes between 12 and 20 minutes. Now the tool changer takes never more than 5 minutes because of the smart changing, because of all the new features we have in there. So if you look over a day's work, you actually gain, you shouldn't really count how much time you've gained in tool changing, because that's not really interesting. You should count how much time you have gained in production. And by using the tool changer, you gain at least 1 hour per day of pure production. Now that 1 hour per day times 200 in a year, or whatever, how many days you work in a year, this is absolute free production time now. And then if you use a bit of our software, which is called the tool optimizer, you can still add another 5% to that. The tool optimizer, what does it do? It will actually figure out an order of bending different parts. Let's say in a day you need to bend 10 different parts, and in a random order you would need to change tools maybe 1 hour. And in the special order, so this is now the order of the tool optimizer, it will put these jobs in a certain order, so then you only need maybe 50 minutes. So you can add another 5 to 10% of pure production gain to that. Okay?
So we want to remove the tool back to the racks. Remove all of them.
So all the customers who have bought a tool changer, the only thing they regret is that they did not buy it on all machines. So it's going to take all the tools back?
Yes,
okay.
Because we're going to show something.
Okay. So that's how the tool changer works. Basically, no more physical stress on the operators. They're very precise. We position these tools within 1/10 of a millimeter. That means that, you know, if you put your tools in manually and you're going to bend a big box, then the operator, he has to open the clamping, he has to shift the tools a little bit to the left, a little bit to the right, and then he has to correct the back gauge a little bit because he did it all wrong. And all these things are now gone because the program fits 100% to the tool position. We, of course, we calculate all this in the Bysoft, and the tool positions are precise within 0.1 of a millimeter. So no more test bends, no more try to see if the tools fit, no more alignment of the tools, that's all gone. All this extra time you waste with manual tool changing is now gone. Another good thing is that your operator can actually find the parts, the next part he needs to bend. He doesn't need to look for the tools. All the tools are always behind the machine, so the operator doesn't even need to know where the tools are. The robot knows where they are. We can also do a mixed work. It's like you put the tools in, like what we just saw before, and then if you need a special tool or a special small tool, you can still put that small tool in by hand, and the robot will know it that you have put in the tool by hand, and it will then tell you afterwards, please take this one out before I take all the automatic tools out. So you are free to use a mixed operation also. We call this a modular tool changer because it is modular. That's a good reason to call it like that. The thing you see beside the side frame where the color changes from gray to white, that is the tool changing module. And you can add that to an Expert Pro. So if you get an Expert Pro in your factory and 1 year later you decide, a tool changer would have been a good idea, then you can actually add that tool changer later. We will set it up. The rear fence goes now to the rear of the modular tool changing system, and then you can run the machine again. Of course, it gets a little bit wider, a little bit deeper in dimension, but that's all. So everything is empty again. The tool changer can also clean the table, is what your operator should do after they have removed the tools. Sometimes they forget it a little bit, and the tool changer can then clean the table. So you can have this quick change, is what we saw now, but you can also have a change with, you're going to rip the wire off.
No.
Okay, you can also have a change with the table cleaning. Next thing is lumps.
Okay.
Yeah? So lumps, I'll show you what lumps is. This is lumps. It says lumps on it. This is our angle measuring system. This is the latest generation. And
You can move by hand to show.
Absolutely fabulous. This thing, you can move them. You know, they've got motors on it, but you know, if you need to move them for one reason or another, then you can do that. There's a laser in here, blue laser light, and here we have a camera looking on the sheet. If the sheet bends, then this one sees this laser line moving, and with that angle now the laser line has viewed by this camera, we can calculate the angle of the part. So we have one here and one at the rear, so these both angles added, that's the actual bend angle. Okay?
So first, before we show the real part with the angle control systems, make you better to understanding how the system work. So I'm going to program the part directly with the control. We have here a special demonstration for you. We have three different thicknesses here. We have 10, 12, and 8 millimeters. And everybody know when we bend this part with the same program, we will get completely three different angles. With the angle control system from Bystronic, we can compensate all of this error, and that's why I'm going to show you with the live demonstration how this works. So I program here a part with 10 millimeters. I don't want to tell to the machines I'm going to bend three different thicknesses. So I choose here 10 millimeters. I'm going to bend with the axis tool. This means the P5 and on the V60, just a part with 90-degree angle. Export. So you will see here, I press this button. Now I activate the angle control systems on. This is on. So let's go. Ich habe schon. กินแรงเนี่ย
Aha, länger, okay.
และอีกครับช่วย So, Gerrit, can you help me, to choose one of these thickness to start first,
Well, you program 10, let's start with 10 then.
Okay, let's go. So I put it in, 10.
So you'll see the blue line coming out. There it is. It's measuring now and it's going to the angle, which is 90 degrees, which is
So
what
I
we
let it
programmed.
here. And then the next one, Gerrit,
8.
8. This is 8. And the last one, the 12.
12.
And now, when you see here, all of these 3 plates, you get this angle.
Now,
Maybe you're asking me, how precise this angle look like. You can see here.
so what does this do for you? This eliminates all your thickness problems. It does not only eliminate all your thickness problems, it also takes out all your grain direction problems. It also takes out all your tensile strength problems. Everything your operators struggle with today to get the angles in the right position are solved with these lumps. You could also see there is absolutely no time wasted with the lumps. It does not add anything to measure and to steer and to control this angle and to compensate it for at the same time. Are we going to do another part?
Yes,
Okay.
we're going to bend the part with the angle control systems.
So that's,
This part here.
we're going to, oh, this is a nice part.
Yeah,
We're going to
see
bend this one.
Is, you will see the hole here is wide, 0.02 millimeter wider than the thickness of the material, and we're going to bend that part with the angle control system. Of course, today you can bend that part also without, but I wish you good luck for you,
Yeah.
to control the part.
So this also means that you get to your results way more quicker. You don't need to make any test bends. You don't need to cut out extra parts. That means that you are going to make more money on your nests because you don't need to cut any test parts anymore. Every single part from the first bend onwards is going to be right with the lump system. Of course, we use the lump system also on our automated machines like the big robot cells, and it's also available now on the small robot cells. So these things are really a must, and the combination of the lumps and the dynamic crowning, that's like the dream team or whatever you want to call it. This one makes that the angle is exactly that what you programmed, and the dynamic crowning makes that that same angle is now available over the whole product. So this is the dream team of bend technology. There is nothing better on the market today. It works extremely well, it's super fast, and of course what it also does, every single angle it has measured at the end of the bend, it will take some kind of a picture and it will store that angle as a numerical value in a file. So you can see afterwards, when you have bent the parts, you can see, part number 1 was 90.1, 90.2, 90, 90, 90, 89.9. So all this information is available and stays available for you. You can pull it out of the controller with an OPC UA interface, and you can use that for your quality control. This is important because now you know exactly when you bend what and with what precision. Okay, this part we're going to bend is quite tricky. Of course, we also measure the spring back. I forgot to tell you that. The spring back is something nasty, which we all have to deal with. The spring back is something we calculate. We can calculate it pretty accurately if the material is okay. So we calculate, like, let's say 2.88 degrees spring back. And that works well if the material has 420 kilos Newton per square millimeter. If it doesn't, if it has 450 or 380 or whatever, the springback varies. And that springback you cannot, guess by looking at the part. You cannot, figure it out before you bend. So if you don't have an angle measuring system, you need to bend, measure, and then re-hit the part. Here, the system figures it out. So we go down to 90, measure when we are at 90, then the beam moves up slowly again, and then it measures the springback. Once it has figured out the springback, then it will go down to that value again. Now this takes, of course, a second or two longer, because we have to move the beam up and down. But it still compensates well over the fact that you never have to make a check anymore. And this part here, okay, it's maybe 3 kilos or something like that. You can compensate for it, no problem at all. You have to take it out, measure it, and rebend it. But if you have a bigger part, let's say a part which is 3 meters and a part which weighs half a ton or something like that, you do not want your operators to take that part out, measure it, and then rebend it. It's dangerous, it's inaccurate, and it's just a big, huge waste of time. So with these lumps, you can bend any part all the time, and it will measure the springback. Also, if you have your big sheets, let's say you have a 40-20 format sheet, you all know that on the sides we have these nice blue colors of the part, of the sheet, and these blue colors mean that the part is there harder, and it also means that the springback is higher there, so you need to compensate for that. That lumps will automatically do that, so you can now start nesting your parts without any spare parts. You can take the parts from part number 1, they will be all right. We guarantee that. The angle position we guarantee is, do we need to move out of here? The angle position is 0.3 degrees, so that's accurate enough for 99% of all the things you're ever going to bend. Okay. That's our RFA clamping. These are, we have a couple of different types. RFA is our most sold clamping. I think it's, I would say 80% of all the clamping systems we sell is actually RFA. Now, why is this important to know? Because our tools will last you a lifetime. They are available on all our machines. And well, I've shown you already the advantages of turning them around and everything. So now here, what you can see here is how we set up, like, it's like not a super complex part. It's a little bit complex because we need an extreme precise gap in between these parts. And if an operator does that, then yeah, you see what he's doing now. He needs to align the tools. He needs to find the tools in these cabinets. And we have quite nice cabinets here. They're pretty well arranged in there. In reality, I see a lot of customers where the tools are somewhere on the pallet or behind the machine, or it doesn't look that nice. This is what I told you about, the adjustment of the dies and the punches we have to do.
Good.
Past it. Okay. So the first bend, this is also a tricky one because the first, can you hold the part in so we can see what's happening? Mm-hmm. The first bend here is it going down?
Yeah, it's going down. That's why you can use only one of the camera.
Okay, yeah. So this obviously go up, and this whole part goes down. So if you would use the lumps here, it will now be completely destroyed by this piece of the part because it moves down. The software knows this, and it will not allow you to put the lumps under that part which is going down. So what we're doing now here is we use the rear lumps only to measure that angle. That works very well. Yeah, let's go. This is what I mean, if you had the lumps there, now you would have a very flat lumps, and you would probably need to buy a new one. Second bend, we have the same thing. So we measure with 1 lumps, and you can program that very easily. You say both, that's our default value, But if we can only use one, then it automatically jumps to 1 lumps. So here we can use both. And this is what Tan said. Now these edges here need to go through that very narrow hole. And sometimes it just doesn't work. So that was today. That was the demo effect. Doesn't matter. Normally you get it like that. Okay. What's the next part, Tan?
Yeah.
We're going to show the sheet support?
Yes.
Okay. So when I check the configuration of most of the machines, we sell a sheet support with it. Everything we sell with the machine, if it's in front of the machine, we automatically supply a parking place with it. Yeah. So you don't need to buy an extra parking place, it already comes with it. Now what's so good about this sheet support? It has side gates, so if you need to have a long part, you can use this as a side gauge. There's 4 of them on all sides. And we have these inserts you can take out. We have different types of inserts. This is a nylon one. We also have one with brushes here. There's also a hardened steel one for if you bend really tough material. And there is also, what else is there? There's one with ball bearings in it. If you have very heavy sheets, it's very easy to use. You can also pull this whole thing out like this. And now you can bend parts which are already up to 2.5 meters long. And what I see a lot of our customers, they make this still longer. You know, if you need to bend a part which is 3 meters, a narrow strip which is 3 meters, then you can just add these profiles. You can just bolt them on the side, and you can make this whole thing go like almost 3 meters. The speed of the sheet support is 100% interpolated with the upper beam. So if the upper beam slows down, the speed of the sheet support slows down. So you can never have a gap between the part and the sheet support. Is it on?
Yes.
Okay. So here you see it moving. So there's actually 3 axes in this sheet support. There is one going up and down, and it will make exactly the same height as the die. Then there is a second axis which rotates this whole plateau here. And then there's a third one which moves in this direction because we need the part to follow the radius exactly. Yeah. Otherwise there will be a gap and you will see counter bends and marks on the sheet. Okay.
Good.
On the controller you see a little sign that says, okay, the sheet support is on. That's how that works. There's different modes. Here it stays up until the upper beam is up and then it goes down, so you can lay it down easily. There's also a synchronized mode where the upper beam and the sheet support both move at the same time and the same speed. It can go all the way up to 30 degrees. And again, the operator only has to say yes or no, switch it on or off. That's all he needs to do.
And you can also extend
showed
this
that
one.
already, yeah. What else is there on this machine? New compared to a thing which is like 10 years old. We have this safety system here. It's called fast bend on our machines. It protects the operator 100% all the time. It's a camera system. It moves up and down with the punch. And at the other side you have the camera, so it sees my finger as a shadow, and that will make the whole system safe. It's also very quickly. It adjusts automatically. If you change your tool height, it automatically moves up and down with the tools, and it compensates for the different tool heights. I think that's enough for this machine for the moment. We can move to our cell, okay? I'm going to show you the little bending cell we have. That's the MCB. MBC operator sees that on the screen also. So the only thing he needs to do is put the pins where he is told on the screen and then put the parts in. Run?
Can we start?
Okay,
Yeah.
we'll close the door.
I let run 3 pieces.
Yeah, okay. So we're going to bend 3 parts on this. I think about half the customers who bought this cell, they bought a second one within a year. I've done the calculations 1,000 times. If you have enough parts, you will have return on investment. Return on investment within a year mostly. What happens is that the speed of the cell depends a little bit on the complexity of the part. And of course, the more complex the part is, the more time it takes, but that's also the same thing with an operator. And complex parts are not really faster on the cell than with a manual operator. The operator has the advantage that he has 2 hands and 2 arms and 2 eyes, so he can figure out easier how to hold the part inside the machine, and he can also take it off a punch easier. You saw that the machine went down pretty slowly on the first part, and that is because it was searching for the top of the stack. Now once it's found that, and now he knows where it is, the next part will go a lot faster. There's a couple of options here also. We have like maybe 100 different end effectors here, magnets or clamps or vacuum cups, and these can be all changed within a couple of seconds. Of course, you need to program them in the Robot Manager, and the Robot Manager makes that you do not need to teach this robotic cell ever. Of course, there is somewhere a cookup panel, because maybe one day you want to move the whole cell and you need to put a robot in in its parking position or something like that. But otherwise, you never ever need to touch the cookup panel. It's all done offline. There is no teaching. There's no corrections for the robot either. So that's what it does. It puts the part down here, takes the neck one. This one will go faster. Because now it knows where the top of the stack is. And you will see here that it will measure the thickness. It goes into that little fork thing with the 2 laser signs on it, and it will measure the thickness. So if it finds a different thickness of what we programmed, then the cell will stop, red lights will go on and things like that. We can see we can see if I check cells at customers, we can see that the price drops if you stay within the simple parts we call parts with maybe up to 4 or 5 bends. You can see the price drop of about 30% to half the cost price of the part. So if you can run this cell, during the night, like half an extra shift, then you can drop the price by 50% off your cost price you have of these parts today. You can program how many parts you want to bend. You can say, okay, make this whole stack all the way to the bottom. You can also say, I want to do 10 parts, then change program, and then change the other part. The little cells we have here, they don't have an automatic tool changer. Very good reason for that is the price. We are super competitive with these bending cells. If you would add a tool changer, then that would raise the price by a big number of percents, and we don't want that. It also, the whole thing becomes not mobile anymore, and that will be a complete different concept. Of course, on our big cells, that's what we're going to see afterwards, we do have our, on the big cells, we do have a tool changer, because on the big cells, the operators don't want to change tools because they are heavy and they are far away, and we want to have 100% autonomy on the big cells. So I think this is the last part. What you will see now is that it will trip the light guard with its own arm, and that will then move the conveyor belt a little bit to the front. It will move up one part length. Some customers put more conveyor belts so they can have a big, huge autonomy. There's also customers who have a drop chute, so parts which are not really critical for scratches, you can just drop in a box. And we can even, to save even more time, we can also have a drop box inside the cell. So now it picks it up, drops it straight away down after the last bend is finished, and you can still save another maybe 10 seconds of your cycle time. So what did I say, which was super important, is the return on investment, mostly within a year, if you have the right products for it, and you will see your product price drop down by up to 50% with these cells. Okay, I think I've said it all. It's weird because normally customers ask questions, but I can't hear anything, so I guess that you have questions. We will see that in our chat afterwards. I told you we had a flat pellet where we can stack up to 240 millimeters high. Yeah, we can show a couple of grippers. These are all standard grippers. They're from our catalog. There are tons more in the catalog, but these are the grippers we use for our demos we do every day. And we don't do demos with our own parts. We also always use customer parts. So there's some with magnets, some with grippers. Our standard gripper is this one here, I think. Where is it? This one, I guess. So you have always a clamping thing here and a vacuum cup. This is a standard gripper, and the other one is probably that. No, I don't know where the other one is. So standard, you get two grippers as a first present with this cell. We also have a kit, a starter kit to change your grippers. You can change your suction cups. You can change the lengths of these grippers. So all that is available. Yeah, let's move to the big cell. Okay. I'll just keep on talking. Our GoPro is on a wire, which was not the plan in the beginning. And we need to do some very clever things here, not to get ourselves killed in the wires and everything. Okay, Marcel, go to the other side of the yellow cable. There. Yeah, okay. So as we approach the big cell in high speed, this is our most standard basic cell. The only option this cell has is the tool changer. Now, to be quite honest, we have never ever sold a bending cell without a tool changer. It would be, not really a good plan to do that. What we're going to do is bend the part. I'll open the door and I can show you some stuff inside. Sorry. So you got two huge sliding doors on the front side and one on the right side of the cell. So what we see inside here is these two big steel pellets. This is what we basically call our part entry. Yeah, that's on that side. Here is not super cleverly solved because we can't get there with the forklift, but that's the way it is here. Then on the front here you see these 6 wooden pallets. This is where we basically put our parts down. Now you can change the pickup and the put down places with one click of your finger on the screen. The moment you've programmed these places as put down or pickup, you can just click on it and say, okay, this is now pickup, and that is lay down, or the other way around. It's absolutely completely flexible and free. What else do we see here? We see these little gray things with the numbers on it, 1, 2, 3. These are gripper holders. On this cell we can have 5 different grippers on the machine. Number 1 is missing. It's not missing because it's already in the robot. And then we can have different grippers here. On the reference table over there on the right, you can store more grippers. Yeah, and so it's up to the operator to supply the grippers which we're going to need for the next jobs. So if your next jobs need these 4 grippers and you can run 48 hours with that, that's all fine, we can do that. If we would attach the cell to a storage system, now you can have unlimited running time of this whole cell. What else do we see here? This is, I think, what is it, 120 kilo? 150 kilo Kuka. Today we use the newest type. This machine has been here now for a year, and we have moved to the latest type of the Kuka robots. one of the big advantages of using a KUKA robot is it has a mean time between failure of 400,000 hours. So it will not break down before it has run 400,000 hours. That's amazing. On the left side, you see our tool rack. So the robot will automatically pick up tools from this rack. And again, there's no programming involved. All the tools were put here automatically by the robot itself. What Tan did, he was just putting the tools in the machine, somewhere the top or the bottom. The robot will figure out where there is space, and then it will put the tools in the rack on the available places. We have an option where we can add more tool racks. Now in this cell, it's a little bit small because this is the smallest cell we have, but we can make cells all the way up to 13 meters, which is like maybe in feet, yeah, no idea, it's a lot of feet. 13 meters, we can have like 4 tool racks in there, and we can have up to about 60 meters of 40, 60, maybe even more meters of tools. Again, here we can have different configurations of the racks. You see the top rack has some punches in it and dies in front. The second rack also, and then the bottom racks, they only have dies in it. You can also have the bottom racks in 2 stages for more punches or more dies. The big thing here, I'll just move over there. This here is our turnover station. This is a full automatic turnover station. These arms, they can move up and down automatically because they were programmed in the Robot Manager. Then the suction cups can also move forwards and backwards, the top and the bottom one. So if you have a narrow part, do we need to re-grip this one? Yeah. Yeah. So we'll see how this works anyway. It will put the part on the suction cups. They can move again. And then we still have some mechanical clamps. There's one at the bottom and there's 2 at the top where we can also clamp a part, which, for example, if we can't use magnets and there's too many holes, there's only one solution left, we use the clamp. So the part is now put on this nylon rail here. It's clamped at the bottom and also at the top, and then we can re-grip the part from the other side or from the same side on a different position, or we can use another type of gripper. This little block here we use to turn the tools around. So if we need swan neck tools the other way around, we'll put them here, turn them around, and then put them in the machine. Over there, sorry, yeah, forgot to tell you about this here. This is our, yeah, Marcel has to stay behind because the wire is not long enough. But this is our reference table. When we pick up a part, we have 2 possibilities. We can just go into the machine and push it against the back gauge fingers. In the fingers there are contacts, and so the robot knows which contact was pushed first, and then it will make a rotational a pivot movement to find the other finger. So if you want to skip this table, that's fine. Otherwise, you would just drop it in this table. It will fall in that corner here. This little thing here measures the thickness. Then we take it out because now we know exactly where it was, and then we can start bending. We are working on a vision system, which it's actually already ready, where we can also skip this whole reference table. With a camera, we can now detect where the part is exactly, how it is pivoted. If it's the right part, we can recognize all the holes. That's almost magic. It's going to come out very soon. Are we going to bend, Tan? Yep, okay. Be careful not to fall.
You have to go out before I start.
Yes. So the job list, where does the job list come from? It comes from our Bysoft somewhere. And has to go close, no?
I would like to say some words
Okay,
before
yeah.
we start. So I have already prepared for you a long part. This part is very thin. You will see here. Very thin. This is only 1.2 millimeter thickness. When you bend this part by hand, it can be very dangerous because it's very short. And for the robot, it's very thin. That's why I'm choose that kind of the grippers, and you will see how the robot can handle that part in the air. And this part belongs to a customer. This is not like a part which is made for a robot. This is the real part for the customer.
This part we're going to bend is for a Belgium customer. And what I said before, the jobs, you can have multiple jobs here. You can run a bunch of parts, a whole stack of parts. You can say, no, I want to bend 50 and then move the stack out again. So all these things are automatically configured, and you can run this cell in a dark factory if you like. It will change automatically the tools, it will change the grippers, and it will continue until there's nothing left to do. Is it starting? Yes, it's starting. Okay. It's changing the tools, grabbing a tool here. It's going to add a punch, I guess, and then we're ready for the whole length of the tools. So then you hear that the clamping is closing, that's right now. What it does next is it will change the gripper. It will put this gripper down. You always need this gripper. This number 1 gripper is the gripper for tool change, so you always need that one. And the other 4 which are left you can use for your production run. The grippers are coded, so it will not pick up a wrong gripper, or it will try to, and then it will tell you that that didn't work. Again, the same thing here. It will try to find the top of the stack, which is here. We're only bending one part of this. Putting it into the reference table. So now we know exactly where it is, and we can go straight against the back gauges. This is a pretty complex part. An operator hates it because he has to flip it over like 4 times. The little calculation I did with the mobile cell, it also is valid, of course, for these big cells. And because you've added quite a lot of value now to your machine, the cost of one part is going up a little bit. So if you bend small parts, and you compare them to small parts being bent on 150 ton or 100 ton in this case with an operator, then you will probably see that they are more or less the same. They have more or less the same cost price. And this stays so. It has nothing to do now with the complexity of the part, like on the small cell. It has now to do with the weight of the part. We can see that this stays like almost up to 15 kilos. 15 kilos. The cost price of both machines are basically the same. Yeah, because here you don't have to pay your operator, it's doing other things. And on the small cell it was the complexity. So here you don't pay your operator. Of course you still need an operator. And if we look at our own cell we use in our own production, we can see that the operator uses 16% of his time to run that cell. Yeah. So we still need that operator. He's doing other things, of course. He's bending other parts on the manual bending machine, but he uses 16% of his time to have this whole cell run 8 hours per shift. And then he puts everything full before he leaves, and it's another quarter of an hour, and then he goes home and the cell will then continue bending up to 10 or 11 o'clock at night. And the moment you go over this kind of limit, this fork scissors limit of 15 kilos, where you would normally need 2 operators. Now all of a sudden you see a huge drop in price of the parts made in the cell compared to the parts made on the manual machine. And that drop in price is like a factor of 3 or 4. So where you would spend probably $16 for a part to bend, a simple part with maybe 2 or 3 bends. Now all of a sudden the cost price, the added cost by this cell is only 4. Yeah, that's a huge difference. Now, why is it so big? First of all, you have 2 operators. Yeah, on your manual cell, you have 2 operators, And these two operators, they take, if you have a part which weighs like 80 or 100 kilos, they take like 20 minutes to make a part, one part with 4 bends, 20 minutes. This robot will only take 4 minutes to make that same part. So in the same time, you can make a huge amount of extra parts and they still cost you no operators, still the same 16%. Okay, are we going to do another part or are we stay like this, Tan?
I think it's more than enough. Right?
Okay,
Yeah.
good. So I think I've explained it all to you. So what is important, the moment your parts are over 15 kilos, and I know Case New Holland, I've bent tons of parts for them, they are way over 15 kilos, so that is like, you know, this is going to be a huge advantage in your production cost using a cell like this. It can run full automatic, change tools, change grippers. It can be attached to a storage system. You can have automatic cassettes moving the parts out. You can have conveyor belts. You can have conveyor belts in. You can have everything almost you can imagine on this cell. Of course, we would not like you to imagine too much. We have a couple of standard layouts we like to stick to, but 99% of the time we can actually do that. And there is plenty of options and features you can choose from to make this cell 100% adapted to your own production. Okay, okay. So, were there any questions?
No.
No?
Obviously, you explained everything very well.
Okay,
so,
yeah.
No questions so far.
Okay, let's wait for another maybe a minute or two to see if there's questions. Hello, Marcel. Marcel was our handicam man.
No.
Okay, good.
No questions.
All right. You can still, of course, shoot an email to Leonardo or anybody else, which is your contact in your local country, and then we'll answer the questions later if there are any. But maybe I was just good for once.
Perfect.
Okay.
No, thank you very much, Gerrit and Tan, to show us these nice press brakes and bending robots. And yeah, then I would say that's it. We can go to the weekend.
Okay.
Thank you.
Okay, thanks for your time. Thanks for your interest, and hope to see you once here in our demo center or on an exhibition or in your plant. Wish you a nice weekend. Thank you.
Have a nice weekend.
Bye.
Bye-bye.
Bye.
Bye. So, eine Stunde nun